So I wanted to do one more video to kind of wrap up session 4 and make sure I get to the stem plot here. But before we do that, I wanted to maybe take one more example from another variable and StatCrunch. We'll go back to the weight perception study, and this time take a look at the weight as opposed to the height. And let's maybe quickly just look at the histogram. Histogram of the weight, see what kind of distribution we got here. Looks fairly normal to me. Let's see here. Now, let's see if we can get some summary statistics on the weight. And I will take all of those. Oh, man, let's see. And I'll get it in the IQR as well. Okay, so the summary statistics give me the mean, the median, the IQR, the range. Something interesting about the minimum there is that's -2. But anyways, how do we analyze the histogram? Is first of all with the shape. This looks unimodal symmetric, so I again think I would go with the mean here. So the average weight is 148 pounds. The median doesn't seem too far off there. Let's see, what else? The IQR is going to help us with the the ability to determine whether or not there's outliers or not. So the IQR is 45, so we got to take 1.5 times the IQR. So 45, IQR is 45 times 1.5. So that's 67.5. I'll add that to Q3. Let's see, over here I see Q3 is 170, so I'll add 170 to that. Anything above 237.5, this is the upper fence. What did I say? 237.5. This is going to be the lower fence. I got to take the IQR in this case minus, or Q1 minus the IQR. So go ahead and delete that. Q1, that's 125 minus 1.5 times the IQR. 1.5 times IQR. No, I did that one wrong. Let's see. Would have helped if I remembered it. 67.5. I'll take that away from 125. So I know this is going to come out to be negative, but I know it's going to be a positive 57.5. So 57.5. Okay. Where'd my upper go? Let's calculate the upper again. Let's see. 67.5 plus Q3, 237.5. Okay. 237.5. Okay, so there I now can analyze my weight. Let's see, I want to sort my weight. I can compute that. Oh my word. So we got, I don't know how many -2s. That and quite a few -1s. That doesn't seem like that came from natural biological collection there. So I would get rid of those that data there. So let's go ahead and we will get rid of that data set, or those individuals from the data set, and then I will just use this. the sort weight. I'm curious what the histogram on the sort weight looks like. Yeah, I think maybe even more symmetric there. And let's see what that does to the average. Summary, stats, columns, sort weight. The average 149. Okay, so I think getting rid of those outliers then could give us a better representation of what's really happening here. Obviously, someone cannot weigh -2 or -1 pounds. I'm very suspicious of the 11 pounder, the 20 pounder. I probably should have got rid of those as well. I think I actually will get rid of those. I don't think anybody's weighing 11 pounds or 20 pounds if they are, how old is this individual? 18 years old? I don't think that's happening. I'm even suspicious of the 18-year-old who's 60 pounds, but I guess that's possible. Get rid of those. So I feel better about that data set, and I'll just go ahead and use that then. Anyways, the purpose of this video is to remind you how to do the outliers, but also a stem and leaf plot. So the stem and leaf plot helps us to organize data, and what we do with the stem and leaf plot is the stems are going to be, so what we're going to do is we're going to take a vertical line and separate the stems from the leaves, and each leaf in the row to the right of its stem gives you the last digit in the value. So in this case, it looks like the value to the left there is in the tens, and the value to the right is going to be in the one. So here's how I would read this. I have a 27, 21, 26, 29, 26, 25, 28, 29, 29, 22, 33, 33, 37, so on and so forth. And then they took these values and they put them in ascending order. Now I can clearly see 21, 22, 25, 26, 26, 27, 28, 29, 29, 29. And there's so many of them, they broke it up into, they stopped at 25 and put it in a different row there. So let's see if we can do that to a data set in StatCrunch. Let's see if that would maybe be appropriate for, I guess we could do it with really any one of these. I guess we could do it with height. So let's go graph, stem and leaf. We'll do it with the height. And let's see what it gives us. Alright, so the height, we got a 49, and then we got a couple of 50s there. Looks like we got a couple of other values, 26 and 38, they thought might be outliers. Here we got 50, 50, 52, 52, so on and so forth. Okay, and there you can almost kind of see how this thing is normally distributed, where we have lots of values in the 60, 65, 70, 75 range, and then very few that are below and above that. Let's see, what else could we do with that? Maybe from another data set. How about, let's see here. I guess we could do salaries just quickly. Let's do a quick little histogram on that, just out of curiosity. The salary of Major League Baseball players. Okay, that looks pretty clearly that that thing's skewed right. Okay, so if I did summary statistics for the salary, I think I would probably use what measure of center? Probably the median, right? Because it's skewed. I would want to use the median. The IQR could be calculated by subtracting those two, or we could go back and edit this and also get the IQR, hit shift and get the IQR on there as well. There's the IQR. Let's see, and then we could determine outliers by taking 1.5 times the IQR. But the moral of this story is that we could, let's see if we can get a stem and leaf for the salary. Okay, so looks like we got a lot of salaries. And then not so many there in the 800,000, 700,000 range. Let's do a stem and leaf with the year. See what that looks like. Stem and leaf for the year. So lots of values of 1985, 1990. I'm sure if I bring it out, 1986 starts here, so on and so forth. So this is a nice little way to organize the values there. All right, so what we got? We got a ways to analyze our histogram with the shape, the center, and the spread. The shape with the symmetry and the modality. The center with the mean, median, and mode. The spread with the range and the interquartile range. Now with the spread, we'll be talking more about the spread using things like variance and standard deviation, which will give us better measures of spread. But remember why we need IQR in the first place is to help us to determine whether there's outliers that we should be worried about or not. Using the IQR criteria for outliers. So now I think we got some good tools to help us to analyze a histogram, which gives us a good visual representation of a quantitative variable using a frequency distribution and histogram.